Hi friends, so in this session we are going to see the influence coefficient. This influence coefficient is required for the multi-degree of freedom system to express the equation of motion. So to express the equation of motion we are going to use this influence coefficient. Now there are two influence coefficients. The one is the influence coefficient and the second one is the stiffness influence coefficient. Okay, so first we'll see the first influence coefficient. This influence coefficient is expressed by a symbol. So that symbol is Aij, and we are talking about the influence coefficient. Now what is meant by this Aij? First we'll understand what is meant by Aij. This Aij is nothing but the deflection at I. Here I'll write deflection at I due to unit load at J. Okay, so what is meant by Aij? Ai means deflection at I, and what is meant by J? Unit load at J, and it is represented by this Aij. So suppose if I write A12, this means unit deflection at 1 due to unit load at 2. So I'll explain this one with the spring mass system. So consider this is the spring mass system with M1 is the first mass, M2 is the second mass, okay, and the K is the stiffness. Now what is meant by this A1? It is deflection at 1, means we will calculate the value of x1. So we will determine the deflection of mass 1, that is x1, but for that we are going to apply the load at 2. So here I will apply the load F2, okay, and this value of F2 should be unit means 1. So when I determine deflection at 1 due to load at 2, that influence coefficient is given by A12. So we'll consider one more example. Consider A21 or A11. Now A11. Okay. So from the above condition, that is mass 1, spring, mass 2. Okay. Now tell me what is this A11? A1 means deflection at 1, but load we will have to apply at 1. So here I will apply the unit load F1 is equal to 1. Now when we consider the unit load at 1, ultimately this value becomes 0, means load at 2 is 0. For first condition we have applied unit load at 2, so force at 1 becomes 0. Okay, so this is the influence coefficient. So if I write the definition of influence coefficient, then I'll write here the definition of this influence coefficient. The influence coefficient Aij is defined as static deflection at I due to unit load at J. Okay, so this is the influence coefficient. Okay, now in this influence coefficient, normally we use one theorem, that is the Maxwell's reciprocal theorem. And in this Maxwell's reciprocal theorem, the value of influence coefficient Ij is equal to Aji. Okay, means if I write A12 means influence coefficient at 1 due to load at 2, then it will be equal to A21, means static deflection at 1 due to load at 2, or static deflection of 2 due to load at 1, and both these values will give you the influence coefficient. Similarly, there is another one term in this influence coefficient, and that is the stiffness influence coefficient. Now, what is this stiffness influence coefficient? This stiffness influence coefficient is denoted by Kij. Now, what is the value of K? It is completely opposite to Aij. See, in Aij we have considered deflection at 1, but here we will have to consider force at 1, that is I, due to unit displacement at j. So if you see, it is completely opposite. Here in Aij it is deflection and j means unit force. Now here completely opposite, force at I due to unit displacement at j. Okay, so I'll write the definition of this one. Now what will be the definition for this? The stiffness influence coefficient is defined as Kij. It is force at I due to unit displacement at j. Okay, so it is completely opposite to Aij, that is influence coefficient. Now we'll consider one example for this case. So suppose if I want to determine 1, 2, for that again I am going to consider the two mass system. So consider the first mass M1, consider the second mass M2. It is having the spring in between. Okay. Now what is meant by K1? K1 means force at 1. So we will have to determine the force value at 1. This value we will have to determine. Now to determine this value, we will have to keep the displacement at 2. Means here we will have to give the displacement at 2 and that will be equal to 1, that is unit displacement. So the displacement of mass 1, x1 will be equal to 0. Okay, so this is nothing but the K12, that is force at 1 due to unit deflection at 2. Now on this we will solve some numericals. Okay, so this is the influence coefficient which is used to express the equation of motion in the multi-degree of freedom system. Now suppose if I consider the three masses, means 3 degree of freedom system, we have 3 displacements, then this influence coefficient is represented by A11, A12, A13, A21, A22, A23, A31, A32, A33. This will be the matrix of this influence coefficient. And if I want to represent the displacement, because here we have determined the value of displacement by keeping the unit load. So to determine the displacement x1, x2, x3, I have considered the 3 masses, then its equation will be influence coefficient into the force. So the equation of the motion will become x1, x2, x3 equal to influence coefficient into the forces F1, F2 and F3. Means ultimately it will become x is equal to A, that is influence coefficient matrix, into F. Similarly, we can write for stiffness influence coefficient, and for stiffness influence coefficient, here we have determined the value of force. So force matrix will be equal to stiffness influence coefficient matrix into what will be the value? X, because we have considered the unit displacement. So it is exactly opposite to this one, and this is the introduction to the influence coefficient. Thank you.